This is Shader Toolbox for Unity URP, a collection of PBR, stylized, and photorealistic shaders for your games. In this video, I want to go over every shader in the pack, and some of the subgraphs and the other features that make it easier for you to make shaders. The first thing I want to point out is the README, which is in the project directory, or the root directory rather. And this will list every single shader in the pack and the properties and what subgraphs are in the pack. And it will also have my contact details. So if you encounter a problem that isn't covered by the README and you can't figure out the problem by yourself, throw me an email because I will try and solve the problem as soon as I can. So let's jump into the things in the pack. The first thing I want to show off isn't a shader per se, it's something that you can do with the shaders in the pack. When you want to do an effect that uses the screen contents, so for this glass refraction effect, for example, you would typically in shader graph sample the camera opaque texture using the scene color node. This texture is generated after all opaques in the scene have been rendered, but before all transparents are rendered. So it only contains the contents of the scene, only the opaques, basically. So nothing transparent is in the texture. But if you want to make effects that have transparent objects in them, in Unity, there isn't really a way around that. But I've added a way to do this. So since all transparents are rendered after the opaques, what I've done is I've injected a second texture called camera transparent texture, which is generated from the screen contents after transparents have rendered. So if I were to very quickly copy this bubble, if you look for it, you'll see that transparents aren't visible for it. So the other bubble, you can't see it. If I select my URP renderer data, so this object, there's one included in the pack, but by default you might have one in settings, and come down here to this copy transparent color, which is a renderer feature I've added. This is one in the pack. And this is the one that copies this camera transparent texture. Once I've added this, then I can access this in any shader. But we want to make sure we access it in a shader that's running after the transparents have all rendered in an additional transparent queue. But this is something we have to do manually. There's no way in Unity to do this by itself. So what I've done, if we go to the top here and look at the transparent layer mask, I have unticked this test layer. And this means that it's not going to render that test layer. But I've also added a render objects renderer feature, which is injecting the test objects back into the rendering loop. But instead, it's putting them after rendering transparents, which is essentially setting up a secondary transparent rendering queue. So if I were to select my bubble in the front here and turn its layer to test, then it is now rendering after all the other transparents. But we still can't see the other bubble through this one. And that's because I need to make the shader do that. So this is the bubble material that it's using currently, and you'll see I have this option camera texture mode, and it's using opaque. But I have a second version here that's using transparent. So if I attach this instead to this front bubble, suddenly I can see transparents through this, which is cool. The only thing to keep in mind, of course, is that because we're rendering everything in the test layer after everything else, you'll get sorting issues. So you'll want to use this in a scenario where this object is in front of everything else that is transparent. So if you have a room that has a window and you want the window to have some refraction, you might attach the glass material and put it in this queue. But make sure that if the player can then go through into the room, then you'll have to swap the material to one that isn't using this. That makes sense? So that's one of my favorite features of the pack. It's just something a little extra that makes it slightly nicer to develop transparent effects. So let's go on to the materials, or rather the shaders in the pack. The first one is base lit, and if I were to find that material, you'll see it's very similar to URP's lit shader. It has all the workflow options, so metallic and specular. We can have opaques and transparents and so on and so forth. The reason I've done it like this, if I go into the graph you'll see that I'm handling all of this through a subgraph called lit default. And the reason I'm doing this is to make your graph a lot neater. Because ordinarily, if you wanted to do like base color stuff and base texture, you'd have the base color, and then you would multiply it with, okay, wanna work? And then you'd like sample your base texture. I cannot type today. And then if you want the alpha, you'd split that off and kind of take the A here. But then if you wanted something more sophisticated, like a height map, then you'd have to use the height map, and then you'd use a parallax mapping node, and, you'd have to output the UV set. This is already getting a little bit kind of cluttered. So this helps to just kind of neaten up if you want to do like a regular PBR graph. You can use any of these outputs you want, or none of them. They all have default values, and you can output stuff directly into the graph outputs that bypasses this node if you want. I just have this to help things be a little bit neater, and a lot of the effects in the pack are kind of based off this. So I have this lit base, just, as a base, I guess. The only difference really is this convert from roughness option. So if you download textures from something like, say, ambientcg.com, or a lot of modeling programs will output a roughness map rather than smoothness. So this option just minuses the values in the roughness map to give you smoothness values, which is what Unity accepts. The next effect is dissolve, and this is kind of a classic shader graph kind of beginner sort of thing, but I've added as many options as I can to this. So you'll see we have the PBR properties we had before, but now we're using alpha clip, and that's how the dissolve is working. It's using alpha clipping. We have two modes here. We have point and plane. So point mode is just away from a point in 3D space, and plane mode is dissolving if we're on like the edge, or if we're on a certain side of the plane. We have properties such as the noise scale and strength, which is controlling the kind of the shape of the edge here, of the lip. We have the strength will make it, it's very sensitive, this Unity, these properties windows. It looks very freaky, some values that you have here. So if we put that down to like 0.3, then the noise is traveling further. Then we have the cutoff points, which I'm driving through skip script at the minute. So if I move this, then this is the point that the dissolve is emanating from. If you're using dissolve mode, plane mode, then you also have a direction, which is the normal direction of the mesh. And I'm also using script for this, so I can rotate this, and it will rotate the dissolve effect nicely. We have the cutoff height, which is how far the dissolve is going. And then we have flip direction, which is self-explanatory. If we flip that, the dissolve happens in the opposite direction. You might have some weirdness that happens, because if your noise strength is quite high, then it have the boundary point is moved. So just be aware of that. And we have the glow color, self-explanatory again. This is HDR, so we can set emissive colors. I can make that very bright if I want. That's a bit over the top. The glue thickness, self-explanatory, thicker glue. And then we have world space. So if we want to use world space, which I currently am, then the point or the plane are defined in world space. Otherwise, it will use object space. So that's relevant relative to the pivot point of the mesh. Then we have use emission. So in shadowed areas, currently by using emission, it ignores any shadows or any, it's on the wrong side of the sun here. But if we untick that, it uses base color. So now this part is dimmer. It's still quite bright because the shadows are not like super duper dark, but you get the point. The next effect is dither transparency. So this one, again, using the same PBR properties as the other effects. But dither transparency is an effect that uses a dither pattern to obscure some pixels of the mesh to make it look like it's transparent on a sufficiently high resolution screen, but every pixel that we are rendering is still opaque. And that means that we're using no alpha blending here, so it can be cheaper on some some architectures and some platforms. But I think some mobile platforms, this can end up more expensive. But basically, profile it, your mileage may vary. The dither related properties we have here are to use a dither texture. So you can supply a texture with the dither patterns if you'd like. I'm currently using the ones automatically generated inside the shader, which is the Bayer matrix. Then we have the dither scale. It's best to use integer values for this. You can use fractional values, but integers work best here just because of the way the pattern is arranged. So this is like the size of each pixel, quote unquote, in the dither pattern. And then we have an opacity slider. So this is exactly what it sounds like. We can raise and lower this and kind of see the effect in action. You can also use the base colors alpha for this, but I've added an extra property just in case you wanted to animate this in a script. I thought having it as a separate property would make that a little bit easier. Next we have mesh explosion, and this one's a bit complicated actually. It's basically moving each single triangle, well, it's moving the vertices of the mesh away from some explosion origin point, in this mode at least. So yeah, we've got the explosion distance, which is how far we go. We have the shrink speed, so each triangle does get smaller as you go further away from the explosion origin. But the shrink speed is how quickly the triangles get smaller. We have gravity, which is how far down we fall over the explosion effect's runtime. And then we have a random offset range, so without this, each triangle travels at the same speed, but we can decrease that. And we have 3 modes for this, and the first one is vertex colors, which is probably the best one. What I've done here is I've taken the mesh, and I've baked the central position of each triangle to the vertex colors of the 3 vertices in that triangle. And what that means is each triangle moves uniformly away from the explosion point. The other mode that uses vertex offsets like this is just vertex offset. And this is way worse, as you can see. If I turn the random down, then you can kind of see the mesh is still the shape it should be. But what this is doing is the same thing, but it's moving each vertex away from the origin point. But because the vertex here for this triangle and the vertex here for this triangle start in the same position, then it moves along the same vector and the mesh stays intact. So this mode only really works if you have a mesh where some parts are detached from the other parts of the mesh, which you might not have. If you want vertex color mode, then I do have an editor tool for this under Tools and Shader Toolbox that will bake the central positions of the triangles into the vertex colors for you and then save a duplicate of the mesh in your project folder. So it's non-destructive. I didn't want to bake those colors in the original mesh just because you might be using vertex colors for something else. And then the third option is vertex normals. So this doesn't use the origin point actually. This is just going to expand the mesh along the normal vectors. Pretty self-explanatory. The next effect is hull outlines. And this is an outline effect that you might have seen before. We basically invert the faces of the mesh. So if we're front facing, then we'll cull the front faces and render the back faces instead, and vice versa. And then we color that mesh, a single color, a block color, and expand along the vertex normals. So in this case, we only have 2 properties. We have the color and the thickness. Both quite self-explanatory, I think. Next, we have lit stochastic. When you are drawing something like a terrain or like a floor like this, quite often you will see texture tiling. And this is a lot easier to see if we use this material. If I just attach that, the tiling is so obvious, so you can see exactly where the tiling is happening. But with lit stochastic, it uses UV offsets and scales to change the pattern at which we sample the texture. So the tiling is a lot less noticeable. The only warning here I have is that every single map that you have here, you have to sample it 3 times when you're using stochastic mode. So that will be 3 texture samples for the base texture, and then 3 for smoothness, and 3 for the normal map, and so on, which can be quite expensive, especially on VR or mobile. But if you wanted to do an effect that uses stochastic sampling, but only does it for the base texture, and you don't need the other PBR maps. I do have a subgraph called sample stochastic that will do it just for one of the texture maps. So I'd bear that in mind. You can have a cheaper version of this effect if you want. And that's one of the useful subgraphs included in this pack that you might want to use. I'm just going to undo all of that. Next we have the glass, which is refracting the objects behind the glass to get this kind of like curved effect. So the refractive index controls how strongly this refraction happens. The glass strength is just the ratio of how much of the scene color we see versus the standard PBR properties. If you turn that to 0, then we only see the PBR stuff. But if it's 1, then it's mostly glass just with environment reflections. The Fresnel power and color. So if I turn the Fresnel color up, then you can see this Fresnel effect, which is just kind of brim lighting. And then the Fresnel power, if we increase it, it covers a smaller amount of the rim. And we can make this HDR as well, so we can make this kind of glowing and emissive if we want. If you wanted this to be some kind of like crystal ball effect, then maybe this would be quite nice. And we also have use emission, so it's the same as before. If we use emission, then it will go straight to the emission output, which ignores all shadows. We can also use the camera texture mode and change this to transparent, but warning, if you do this with something that is not in that extra rendering queue, so if we're not using the vendor objects for this, then you get this kind of like infinite hallway mirror sort of thing, which in some cases it just is bright kind of flashbang and it doesn't look right. So just make sure you don't do that. That might be undefined behavior with how it actually pushes. I'm not entirely sure. Next we have gooch shading. Obviously I'm a fan of this. I don't know if you've noticed from this channel yet, but I am obsessed with geese, and it kind of sounds like goose shading. But basically, this is a non-photorealistic technique that you'll see in CAD applications, and the point is to emphasize the directionality of different parts of a mesh. So we use warm colors for the parts facing a light source, and cold colors for the parts facing away. And you can customize these colors, so you can have red there instead if you wanted, and you could have like a lighter blue for the light part. Then we have the temperature offset, which is controlling the mix between the warm and cold. And then I also have added the specular highlight. You won't see this in every gooch shading application, but I thought it would look quite nice and stylized, so here it is. If you increase the power, the highlight gets smaller, vice versa. You can make it really big if you want. It kind of looks a bit crazy. And then we also have use HCL color space. So HCL stands for hue chroma luminance, and it more accurately models the way that the human visual system would perceive a straight line kind of change between this warm color and this cold color. If you use RGB space instead, then the straight line between these two colors is it goes through gray, so it's a little bit weird. But HCL tries to preserve the lightness a lot better and have like a nicer transition along hue. So you might like the other version. HCL is a little bit more expensive just because you need to do the conversion, but I think it looks nicer this way. Next we have bubbles, which we already kind of saw. But this is very similar to glass, so we have the refractive index as before. And we also have which one is it? It's the iridescent strength, which is the ratio of how strong the Fresnel portion of this shows up, because this iridescent color is handled through the Fresnel. So we have Fresnel power, and that means that the iridescence travels further or less far across the surface. And then we have this noise. So if I turn the noise scale down to 0, it's not the noise scale, it's the noise strength, sorry, then we'll see that it is just perfectly circular. But the noise strength is how much the noise influences the pattern. And the noise scale is just the size of the noise pattern that's generated. So we can have this very, very kind of fine noise if we want. We also have the flow direction. So I've made an attempt to make the iridescent colors flow in a certain direction. It's not super noticeable, but you can change this and it will try. Now it's hopefully visible that the noise is traveling a little bit more along the X than it previously was. And then we have the iridescent flow speed, which is very noticeable. Now we have a rave, I guess. And then, of course, we have the camera texture mode, so this could be transparent, but we don't want it to be because it's not in IQ. Next, we have the heat distortion. I want to make sure I get the right one. Here we are. So this is distorting the objects behind this mesh. There is one here, I promise. So we have the origin point, which is the glowing circle in the middle. And this is where the heat haze is strongest, because I have a fall off, which means that at the edge of the mesh, the heat distortion is less strong. If I turn this down, then this fall off is less pronounced. So the edge is also quite a strong distortion now. And turn that back up. Then we have the distortion map, which is an encoding of the vectors along which the distortion effect happens. And this distortion map is scrolling across screen space and effectively distorting the camera texture. The strength, if we increase that, quite self-explanatory what that's doing. It's just making the vectors offset the camera texture slightly more. And then we have the velocity, which is how fast the texture scrolls. So I can make that something absurdly high and it will be scrolling like really quick over here, but maybe something like that's still also quite high, but make it 1. It will travel left to right as well. And then the tiling is how many times this texture is going to tile in screen space. So I can make that higher, and then we get more fine-tuned heat haze. This effect also lets you use the transparent camera texture, but I think you get the point of that already. And then the last effect is Voronoi lava. So Unity's inbuilt Voronoi node makes it quite difficult to get a measure of how far from a Voronoi cell edge you are. But I've written a new version of Voronoi that makes it much easier to do that. So the way this works is we have 2 texture layers, and the first one is for lava, and the second one is for the rock. And this has the same properties as we've seen before for other PBR materials. But then we also have these Voronoi properties. So the density is just how many cells we have per unit distance in world space. The angle offset actually might help expose something about how Voronoi works. If this is 0, we start off with this perfectly uniform grid. And then as we increase it, what Voronoi actually does is each corner has an offset vector associated to it, and it starts off in the middle of each grid. And then as we increase that, we're offsetting the center point slightly. And what Voronoi does, the only thing it does, is for each pixel, we'll find out which cell midpoint we are closest to. So for this, if we increase this a little bit, I'll show you. So for this middle part of the lava, it is exactly equal distance from this midpoint and this midpoint. But for something like, if I find a nice kind of, there we go. This part, exactly in the middle of these 3 parts of lava, is exactly the same distance from this midpoint, and this midpoint of these 3 Voronoi cells. That's all Voronoi does. Then we have the thickness, which is just obviously how thick the edges are, the edge detection. And the fall off is how smooth a transition we have between lava parts and rock parts. So if this is 0, it's a hard boundary. And in fact, we can have both 0, there's actually only rock. And we can only have fall off if we want kind of a very smooth or very thin lava channels. Which I think still looks quite nice. Then the only remaining property is the swap texture layers, which does exactly what it sounds like it does. It just swaps the lava and the rock around. It actually sorts all these properties around, which is kind of cool. And that's all of the shade effects in Shader Toolbox for Unity URP. The only thing remaining is the subgraph library, which I'm not going to go into super detail about, but there are some nice things here. So I have the Voronoi I mentioned. There's a node here to find perpendicular vectors. So you feed it one vector and it will find a pair of vectors that are perpendicular to it and to each other. Refraction, which I'm surprised isn't already a node. And then we have stuff for color conversion, so the HCL space we had before. Stuff for lighting, so getting the main light and the ambient light, which is stuff that ShaderGraph can't do. We can get the main light's direction, but you can't get the color and the attenuation but get mainlight lets you do that. And yeah, just a bunch of other subgraphs that I think would be quite useful. So that is Shader Toolbox for Unity URP. Thanks for watching, and if you decide to buy the pack, then thank you very much. I appreciate your support, and I hope this will be useful for your games. Until next time, have fun making shaders.